Hi, Layla. You okay? Laura, will you listen to this timer for me, please?
We do? Really? Bless. Oh,
Yes, ma'am.
Definitions, expressions, do you have to just write the whole thing?
Nope, first sentence is fine. Alright, let's talk about our learning target mathematical practice. Somebody read the learning target for me, Niall. Go! I can use algebra tiles to explore area. Fabulous. Mathematical practice. Somebody else. Go ahead.
I can model with mathematics.
Go ahead, I'm sorry.
I can model with mathematics.
Fabulous. So, if these are algebra tiles, what do you think we are going to be doing today? Somebody help me out. Go, Michael. Finding the area using what? Algebra tiles, modeling. Good. All right, send me your resource manager, and while your resource manager is coming up here, please clear your desk with your book to the side. You need lots of workspace. You need one baggie per person at your table. One baggie per person at your table. So here's 4. 1, 2, 3, 4. 1. You may open the bags and play with the algebra tiles. You have 30 seconds to play. About 30 seconds to explore the algebra tiles.
Okay, so some are like I don't know what I'm supposed to eat, but I'm just so happy.
Some are really small.
It's like those
I'm gonna separate them into groups.
I'm making it a person. I'm making
Mickey
Mouse. So that's what I do with that's what I do when I have to play. I make Mickey Mouse.
Abby, will you turn on the lights for me?
Mickey Mouse. It's beautiful. It's beautiful in here.
Seeing some beautiful designs. You all are so creative.
Oh, yay.
This is your
Mora, chill. He said good morning.
I do 10 square.
All right, ladies and gentlemen, 5, 4, 3, I need your eyes up here. 2, hands off the algebra tiles. 1, I should have a whole lot more eyes up here. Good morning to you too. All right, with your team, I would like you to start working through 6-80. 6-80 in your book. And I need you to think about, where have you seen concepts like this before? We are going to have about 6 minutes to work through this problem. 6-80. 80. You have about 6 minutes. I'll set the timer.
Okay, so with your team, your teacher will provide your team with a set of algebra. Remove one from the bag and put it on your desk. So everybody take one of these and push it on your desk. And then just push the other one. Please give it.
What, babe?
Trace around each shape on your paper. Look at the different sides.
Oh!
So I'm gonna trace them.
The big square and the rectangle have the same side length. And 5 of these will be this. And then 5 of these would also be this. Yeah, so 5 of the little ones will have the side length of
And they have 3
both
different.
the
Those are the same.
Let's first trace it.
Hey, what's your team discuss? What's your team discussion?
Send me your task manager, please, for a huddle. Send me your task manager for a huddle, please. 1, 2, 3, 4, 5, 6, 7, and struggle bus.
Yeah, I am task manager.
Okay. Make sure that on 6-80, make sure on 6-80, this is supposed to be secret information. People are meddling here. 6-80, do not split this up. I want you discovering this with your team. So don't say you do A, you do B, you do C. Everybody's working on it together and really build those discussion concepts. Got it? Got it. Bye.
Understand this.
We're just like
Tell us to
tracing. Yeah. With your team, discuss which shapes have the same side lengths and which ones have different side lengths. To share ideas in class. On your trace drawings, to color code links that are I know all these people, like, a certain number of these go into the square.
What did you when you saw things like that? Okay, so a square would be a potential. What else do we call them? A quadrilateral is another name for a square, yes. When we had like these little bitty squares, these long skinny ones, and these flats, when did we use those? we kind of use them as cubes. When we used them last time, they were cubes. But what are those called? They were green.
What does it start with?
They were green. B. And then A. Base 10 blocks. So what did we call these with base 10 blocks? Units. Then what were these? Tens. Hundreds. But what did we call these generically? Rods and flats. So when you're referring to them, you can use those terms.
This is a unit and this is a flat.
Nailed it.
You should write that on here.
Alright.
No, like on the show.
That would give it away. Then there's no exploration.
That's the point.
No. Seeing some really good people that are engaged.
And then okay, so we can like how about like no, you don't need it. Okay. I'm doing really bad.
You have about 1 more minute.
What?
We have to figure out you can use the unit tile to find the side length of other rectangles. Why are
This would be X5. Like that.
I think
This 5 of these would be this. Or something like that. Then we have this is X20. That whole thing doesn't work. Because so this side, the length.
Good conversation.
Be prepared to share your ideas with the class or
For me.
okay, you can use the smallest one to find the other links because you can use the small so you can go
So what sides do you notice that are similar? This one what? Be a little bit more specific. Is it a tens? Okay, so that's just how you're referring to it. Love it. Love it. Okay, keep going. Good job, guys.
Miss Gibbons.
Thank you. Ladies and gentlemen, will an extra 2 minutes help you out?
Sure.
Yes or no? 2 minutes.
we have to only do the sides. Like if they have the same length on a certain side, we make the same color.
other two sides purple. Then this is gonna be purple on each side.
Yeah, on those sides.
Why did I say we needed 3 colors? Oh yeah, there are 3 shades. But we only need 1.
Color the outside. Any outside that matches that length, color in that same color.
Or do you
Need help? So part B. Each type of tile is named for its area. In this course, the smallest square will be called 1 or the unit tile. Can you use the unit tile to find the side lengths of the other rectangles? Why or why not?
Okay, so yes, you can use the unit tile to figure out the other side lengths.
That is exactly what. If you cannot give a numerical value for the other side length, you let you know the cost.
So it would be and then like 4 unit.
I don't know what Miss A. Well, Miss Ames, I get. Even Miss Maston, I sort of get. But Mr. Brockman, you're not into Miss Xavier. That's confusing. I'm sorry.
So why can you? Because I just take the small ones and compare them to the bigger ones to find the latest. Yeah, you can because like it has to like say like one side of the
I love your reference.
Here, let's see what you do. Okay.
Alright, I apologize for the delay. My little camcorder thing filled up, so I apologize. Alright, in front of you, I want one of each of the different kind of tiles. So you need a flat, a rod, a unit, all in front of you.
You know what they're called?
Well, that's what they're called? Okay, we're going to change those names.
One of each. Alright, what did you notice when you were exploring with our algebra tiles? What did you notice? Niall?
I noticed that the unit, the smallest one, can you can find the other lengths of the flat and the rod by putting it into putting the unit into each one of them.
Okay, somebody else. Build off of what Niall said.
I noticed that you could use, instead of using the unit to fill up, what is this one called? The flat, you could use the rod because it will be quicker.
Okay. Can anybody else add on to what they've said? When have you seen concepts like this before? Somebody else. Ari, when have you seen something like this before? Base 10 blocks. These are very similar to base 10 blocks. Where you had your flat and your rod. Let's see if I have any units in here. There's a unit. Alright, with base 10 blocks, what did we know about those outsides? Who has my ball? Somebody else. What do we know about those outsides? What did they build up to? Talk to me about our base 10 blocks.
Well, you actually knew what, like, the, how many units were on the rod or the...
Okay, so like some people were saying, if you use 5 of the units, you can make one of the rods in algebra tiles. If you use 5 of the rods, you can build up to a flat, correct? Except, what's different between algebra and just straight arithmetic? Somebody help me out. What's different between those two things?
Well, the base 10 blocks, they're like 10, and then the algebra ones are 5.
Okay, so we could say that they're 5, but I'm asking what's the difference between algebra and arithmetic? Somebody else, somebody who hasn't talked. Tristan. Okay.
Variables.
Variables. Variables make those two concepts different. So today we are going to get into using variables. What is a variable? Somebody remind me. Somebody who has not talked yet. Chandler, thanks for volunteering. What's a variable?
I know this.
You do. You can use your group if you need them. Help them out, group. What's a variable?
It's for the unknown number in an equation.
Love it. An unknown. So because we're using algebra tiles, now we're working with the unknown. So when you trace, so this is where you want your individual spirals out. tiles, what are we doing? What do you think we're doing up here? Okay, back to your warm-up. How did you find the area when you were doing your warm-up? What did you do? Who has my ball?
You just.
Do I? Oh my God. Look at that. Ariane, what did you do in the warm-up? Length times width. Oh, we're going to put this up here because I'm really tall. Thank you. Length times.
She's not like her tippy.
Length times width. So, if we're naming our unit, what are we multiplying? Who has my ball? Ariane, toss to somebody else. Surprise them. What's my formula here? What am I multiplying? If I'm doing length times width. 1 times 1. Which equals, conveniently, 1.
Yay!
And we're going to call it our unit. If I'm writing,
You're right.
thank you.
I didn't know what.
Thank you to those of you that are copying this down. I appreciate it.
I messed up. I did, but then I messed up because I didn't know I need to like formula. Okay,
Okay? So now we're moving on to our rod. What's similar about the rod in our unit? Who has my ball? Toss it. What's similar about our rod and our unit? Brooklyn helps out.
Well, our unit can fit into the rod, which
Okay?
helps us.
I'm talking about the side lengths.
Oh, the side links.
What's similar?
If you put the unit up against the rod, 5 of them would be.
Looking at
Oh,
this.
one. The top
The top
would equal 1.
is 1 and
The bottom would equal 1.
the bottom is equal to 1. Good. You're just getting ahead of me. You're good. And what did we say was different about algebra versus just straight arithmetic? What do we not know, Ari?
Variable.
The variable. So if we don't know what this side length is, what are we going to use? A variable. These are going to be used as x's. Because this is our unknown length, we're using an x. So what's our formula going to be for this tile? Somebody else. Who has my ball? I do? You do. Somebody does. Somebody else. Emily.
X times 1 times X times 1.
X times 1. Love it. Yes. I probably should have done this up here. You're right.
I'll split 2x.
X times 1, which equals, if you have one group of x, what do you have? X. So this is your
Formula.
x tile. So whenever you see a rod in algebra tiles, that's going to be your x. We call it x. Yes, ma'am. Interested. this quote? Math is pretty, and that makes you pretty. That's what she wrote on my little board book.
I don't understand that.
Okay, so what's my formula here? How do I name this? Where's my ball? Toss somebody else. Surprise somebody. Ah, George.
What is the formula for it?
Yep.
X times X.
X times X equals, remember when we did our prime factorization? If we had 2 times 2 times 2, what would we put to shorten that? The exponent. Good. So if we have X and there's 2 of them, how do we write that? Katie? X to the second power. Good. Or X squared.
Is that what the thing?
So this is going to be our X squared tile.
Can we use more pretty colors?
Here's my challenge for you. In your groups, if I have another rod, what could we name this rod? Talk in your groups. You have about 1 minute.
So we would name it. It would still be X.
Well, no. X2. Yeah, X2. Because it has 2 of the X times.
Okay, so.
Okay, come back to me. 5. Of course I do.
That we shouldn't use X, we need to use a different variable. So
We should use X. We should use a different variable. What
So-
variable would you pick?
Y.
You picked Y. We're not getting into that this year, but this is a great little builder for next year. When you all are in 7th grade, you're going to be using multiple different variables. And he said, give me just 1 second, girls. He said that we want to use Y for this one. How come we didn't just use X? It's a rod. How come we didn't use X, Emily? Oh, terrible throw. Somebody help me out, please.
To use Y because it's the
already came
same
back.
as
Thank you.
X. It's bigger than X.
It's bigger than X. It's a different length. It's a different unknown sideway. So we can't use that same variable. Good. All right. Next thing I need you to do is with your groups, I want you to go on and work on 681, 82, 83, and 84. I will put the instructions back on the board. You have about 15 minutes to work through this. You may go.
Sketch 3 tiles on their paper. Jeremy labeled each tile. Jacob, read it out loud.
Jeremy labeled each tile with an X. There are 3 X tiles, each with dimensions of 1 by.
Jacob hasn't read
Total
it.
area is 3X squared.
How do we name our tiles?
So,
How did we get those names though? I didn't just make them up. Which is the formula for area. So we're just naming them by their area. That's all that means. 1. 2. All we're doing is creating expressions. What's an expression? That was your vocab word that you looked at. Go. Adding, it's not an equation, though. There's a difference. What's the difference between an equation and an expression? And an expression doesn't have an answer. So all you're doing is combining all these things that look similar. This is what we're going to be getting into. So if you're looking up here, and we're naming these, what are my 3 different names that are represented up here? Go, Ari. Okay, what are we calling them in alphabetized?
Unit,
squared tile. How many x squareds are there up here? 1. So we would write x squared plus, what are we combining it with? Layla.
Oh wait, I have a question.
Okay.
Since like if you have like x8 and then plus.
Well, there is no x to the 8th because that would be multiplying x times x times x times x. So that would be an octagon. So if we're talking about how many x's there are, we would say 8x. Does that make sense?
Yeah, and
Okay.
also I don't know, I'm confused. I'm just gonna
Okay, well that's why I'm trying to clear up that right now, and then we'll talk more if needed. Okay? Okay, that's why we're going over this right now. Fabulous. Okay, well this will give you a little bit more information that you can take back to your. So if we have x squared plus how many x's are represented on the board right now? 3, so plus 3x plus how many units are there, Demaria? Plus 6. So that's our expression. It's x squared plus 3x plus 6. Make sense? So when it tells you that it wants you to name the representative of the area, that's what you're writing. It's that little expression. Does that make sense? Good? Alright, goodbye.
I'm confused how you add x to plus like a regular x
Yep.
or you
Yep.
6-82
Okay.
like at first we thought we had to put these together, but looking over here we don't. So how would we do it? Like if it's all spread out?
Okay, so if this one, you would have x squared plus 1 plus how many x's are together here? Plus 2x plus x plus what are those? They're all units, but they're together. So if we combine 5 of those units, what do we write? If there's 5 units combined, 1 plus 1 plus 1 plus 1 plus 1. Plus 5 plus 1 plus 1 plus x squared plus 1.
I think we already just got caught in my
Does that make sense, Michael?
Yeah.
Okay. All right, you have about 2 more minutes, and then we're wrapping up. Yep, through 84. Keep going. 84. Morgan, what was it?
tiles to answer the questions.
Okay, you can start working on it. Don't
Take your
you can read your don't push away.
Well, this is an awkward time.
I love the amount of vocabulary words that I'm hearing right now. Expression and x squared. I love it. What's up, y'all? Do you just make these like a square?
I thought that was unit because that's right. Those are just units.
Oh, I don't know.
The
Red.
little ones are you.
Be a scary reality TV show. Alright, what's up, girls? What? This is 5 units. They're just put together. Just like this is 2 x's.
Wait, is
They're
this
put
what
together.
we're supposed to do and then like
No,
count
no, no,
the...
no. It's units. Individual units. Plus 10. Yep.
Okay, so
No, do we like do this and then find the area?
Yes, but it would be, what's this for?
Oh.
Remember how when we do the generic rectangles, how we multiply and then we add up everything in the middle? So this is already multiplied for you by their names. Then we're just adding it up for our total. Does that make sense?
So multiply each.
So we're not. They're already multiplied, honey. So what is this for?
100. No, that one.
X.
which is also known as x squared plus no, we're not thinking about this as 5 anymore. The only time it would be 5 is if you have 5 like that. X plus 5. Because they're already multiplied. Okay?
So basically, X plus X
Plus X squared plus X squared plus 5. They're already multiplied, sweetie.
these would be
They're
like.
multiplied when...
Wait,
So 16.
that's what I have.
Well, 16 is if you had 16 of these little
Would it be
guys.
5X?
Yes. Yes, it would. Why would it be 5x?
Because
What about those? Those are x's. What are these called? X squared. What are those called? Ones. How many ones are there? 5.
so what? So would it be 5X?
5x plus how many x squared? Plus 2x squared plus how many units? Plus 5. And that's your expression. You are not going to fail it, Ellen. What'd you say? This is day 1 of algebra, baby. It's going to get better. Yep. All right, ladies and gentlemen, I need you to get a blank sheet of paper out, please. You have about 10 seconds. You have 5 minutes, so you need to finish this learning loss. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What was our learning target for today? More. Yes, it is. Emily.
I can use algebra tiles to explore area.
Okay, how do we do that today? Somebody help me out. How do we use algebra tiles to explore area? Somebody give me an example. Katie, thanks for volunteering. How do we use algebra tiles to explore area? How do we name our algebra tiles? We multiply using what formula?
Length times width.
Length times width, which is also the formula for
Volume.
area. What did we do with our expressions when we had them separated? What did we do with our expression? So if we had this expression up here, how would we write that as an expression? Somebody help me out. My facilitators, you all were up here when we talked about it.
Yeah.
How would we write what's on the board as an expression? Somebody help me out. I'm about to just call on somebody.
Haley's volunteering.
Ari.
We would add them all together.
Okay, so what expression would this look like?
It would be x2 plus
Which is also known as what?
x squared
X squared, good. Plus
3x
3x.
plus
Plus 5, fabulous.
no, it was 6.
Okay, I got it.
Oh yeah, like
That's fine, I know that. Okay, that's okay, thanks. What's another way, instead of combining all those things, that we could write that expression? We have x squared plus 3x plus 6. How else could you write that? We already have, we're still representing the same thing, but we're creating another expression that looks like it, that is equal to it, but looks different. What's that called? If it's worth the same, but it looks different, what's that called, Niall? Equivalent. So we need an equivalent expression to x squared plus 3x plus 6. How else can we write it, Niall? want you to title it Algebra Tiles. This is your exit slip for today. Make sure your confidence level is in the top left and your name is on your paper. I want you to tell me what you know about algebra tiles. I want you to talk to me about what they look like. How they're named. And also some examples of equivalent expressions. So you have 3 different parts to this learning log.
Can we trace these?
Absolutely. You have about 5 minutes to get this done, ladies and gentlemen. As soon as it's finished, I need all the algebra tiles packed up. Your resource manager needs to bring them up to the cart, and you need to turn in your learning logs before you may pack up. You have about 5 to 7 minutes to get this done. The more information you give me, the more I know you understand. Awesome job today, guys. I loved your use of vocab.
That's exactly what I want. How did we know that's called the next year title? How do we know that's the next time? How do we know that's
My people that need to go to the library, go ahead and turn yours in, and you need to go ahead and go.